This example is just kind of like the last one. So we have cosine 2 theta is equal, plus 3 sine theta minus 2 is equal to 0. So we have choices for cosine of 2 theta. Be careful with the choices you make, because if we're not careful, we add an extra trig function into this. Since we have this sine of theta, and I want to live really in one trig function, I'm going to use 1 minus 2 sine squared theta for the cosine 2 theta formula. Okay, I don't want to be adding another trig function into the mix here. So I'm replacing cosine 2 theta with 1 minus 2 sine squared. That way, I only have one trig function to deal with. Choices you make matter. All right, let's clean this up and see what we get. So negative 2 sine squared theta plus 3 sine theta. 1 minus 2 is equal to negative 1. And then I'm going to multiply everything by negative 1 so that we get our signs right. Minus 3 sine theta plus 1 is equal to 0. All right, looks like a quadratic. Write it like a quadratic. So this is going to look like 2x squared minus 3x plus 1. Okay, oops, x squared. Factor this. So this is going to be easy, actually. These are just going to be minus 1s. So 2x squared minus 2x minus x gives me minus 3x plus 1. Okay, so 2 sine theta minus 1. And then sine theta minus 1. So sine of theta is equal to positive 1. That occurs in one location in degree measure. That occurs at 90 degrees. Think of the graph if it helps. Okay, helps me. And then sine of theta is equal to 1/2. Occurs in two spots. In the first quadrant, that happens at 30 degrees. And in the second quadrant, that occurs at 150. All right, so here's another one. Similar to what we've done, another kind of good piece of advice. If it's squared, you can manipulate it. So, like, I can't really mess with this sine. There's nothing I can, like, think of to be like, oh, sine, I can turn this into something else. Like, it doesn't happen. But cosine squared, I can. If it's squared, you can manipulate. And we have, like, our most favorite trig identity in the whole wide world. Sine squared plus cosine squared is equal to 1. If I manipulate this formula for cosine squared, I can replace this with 1 minus sine squared, and I can only be in sines, and that's going to be key. Like I said, the most important thing with solving these trig functions is we want to get only be in one trig function. We don't want to have like multiple trig functions because that's going to be a nightmare. So I'm going to say 4, and I'm going to replace cosine squared with 1 minus sine squared. It's 4 sine x minus 5 is equal to 0. All right, so let's distribute. So I have 4 minus 4 sine squared x plus 4 sine x minus 5 is equal to 0. Let's rewrite. 4 sine squared of x plus 4 sine x. 4 minus 5 is minus 1 is equal to 0. And then I'm going to divide through by a negative. So this becomes 4 sine squared x minus 4 sine x plus 1 is equal to 0. All right, so make this look a quadratic. So 4x squared minus 4x plus 1. So I've also have this little trick. If you struggle with factoring with a number in front of the x squared, here's a little like weird technique that works all the time, but I don't know why. So don't like ask me, oh, why does that work? I have no clue. It's like a little algorithm that works. So what you can do is you can take this first number and multiply it by the last. Told you this doesn't make any sense. So you get x squared minus 4x plus 4. The idea with that is that turns into something you can factor. okay, hopefully. And then you say, okay, x minus 2, x minus 2. And what you do is you take the number you multiplied with, this 4, and you divide each of these little terms, this number, by that number. So I have x minus, it'd be 2 over 4. We simplify this fraction, and then we would just get x minus 1/2. And then what we do is we actually rewrite this fraction with the 2 in front of the x. So it looks like 2x minus 1, 2x minus 1. It's just this weird little trick that I have when I was teaching high school that I would help with my kids. So if you like this method, go for it. If you like the quadratic, go for it. If you just like to factor it normally, just do what you got to do. So anyways, this factors as 2x minus 1, 2x minus 1. So this is going to factor as 2 sine x minus 1, 2 sine x minus 1 is equal to 0. Oops, 0. We're not going to solve it twice. We solve it once. It's the same thing, so I don't need to double solve. It doesn't do anything. So 2 sine x minus 1 is equal to 0. Sine of x is equal to 1/2. So x is equal to, we are, all solutions. That's exciting. Okay, sine of x is equal to 1/2. Let's do radians. 1/2, 30 degrees, pi over 6. So pi over 6 plus 2 pi k. That's one solution. And then the other solution is going to be in the second quadrant, 5 pi over 6 plus 2 pi k. Looks fantastic. Love that. Like I said, if you need help factoring, get at me. I can give you some stuff to help you factor. It's not going to quite go away yet, and especially in this section that we do a lot of it in 6.2, 6.3.